Hello friends, welcome to my classroom. Today we will have discussion on discrete probability distribution, and under discrete probability distribution we study two important distributions. One is binomial distribution and another is Poisson distribution. So we will start with the understanding of a random variable. A random variable is very simple. Let us take a variable x, and this x takes the values based on outcome of a random experiment. That's it. It's a very simple definition. Let's understand this with an example, a simple example. Let us take an example of tossing two coins. So if you toss two coins, there are four outcomes. So what are the four outcomes? Both the coins may show heads, HH. First coin may show head and second may show tail. This is second case. Or one more case. First coin may show tail and second may show head. And finally one more case where both the coins will show tails. So these are the four possible outcomes of this random experiment. Now let us define x. Define x. In our example, let us define x as number of heads. It can be defined in any other way also. Let me take it as number of heads appeared when I did my experiment. So this x takes different values depending on different outcomes. So let us take our first outcome. First outcome is HH. That means both the coins showed heads only. So when the outcome HH is there, the number of heads is 2. So x will take the value 2 because 2 heads are there in our outcome. In second outcome, what will happen? HT. In HT, one coin is showing H, other is showing tail. So only one head is there. So x will take the value 1 because it takes the value only on the basis of number of heads appeared. In third case, TH. Here also only one head is there. So x will again take the value 1 only. And in the last case, TT, x will take the value 0 because there are no heads. No heads appeared. So x is taking the value 0. So x is taking these three values based on four outcomes of our random experiment. So this x is taking the values based on the outcomes of the random experiment, and x is called as a random variable. Random variable. So now suppose x takes the discrete values, then it is called as discrete random variable, and if takes the continuous values in an interval, it is called as continuous random variable. In our example, x is taking the values 0, 1, 2, discrete values. So whenever x takes the discrete values, it is called as discrete random variable. And suppose x is taking any value in an interval, let us say interval is 2 to 5. It can take any value between 2 and 5. It's not restricted to 3 and 4. It could be 2.1, 2.7, 3.4, 3.8, 4.6, whatever it may be. Then it is called as continuous random variable. Hope you have understood what is a random variable and what is the difference between discrete random variable and continuous random variable. Now let us understand what is the probability distribution is. So probability distribution, let me write here only. I'll explain it with the same example what we have here. So x is taking three values here. One is 0, one is 1, and the last one is 2. So x is taking three values. X is taking the values 0, 1 and 2. So now what is the probability that x takes a particular value? Let us say we need to calculate what is the probability that x takes the value 0, because x is taking three values 0 and 1 and 2. For all these cases there will be a probability. Now what is the probability that x takes the value 0? So in our outcomes, 4 outcomes are there. Order of s is 4 here. So out of 4 outcomes, first outcome is HH. In case of HH, x is not taking the value 0 because 2 hits are there. X will be taking the value 2 there. So in first case, x is not 0. In second case also x is not 0. In third case also x is not 0. Only in the fourth case x is 0 because there are 0 hits. There are no hits. So in one case out of 4 cases available, it is 0. So probability that x equal to 0 is 1 by 4. Let us fill this probability in our table. P of x taking the value 0 is 1 by 4. Now second value is 1. What is the probability that x takes the value 1? So HH case, x will not take the value 1. In HT case, x takes the value 1 because one head is there. In third case also only one head is there. There also x takes the value 1. These are 2 cases which I have written in the square. So 2 cases out of 4. You can write it as 2 by 4 or simplify it to 1 by 2. So 2 out of 4 cases are taking the value x equal to 1. So the probability that x is equal to 1 is 2 by 4. Now the last case, x is taking the value 2 is only one case, first case out of 4. So this probability will be 1 by 4. P of 2 will be 1 by 4. Now the x values along with these probabilities, xi along with P of xi is called as probability distribution. Okay, hope you have understood what is a probability distribution. And this table, what I have written here, is called probability distribution table. Since x is taking the values, discrete values, it's called discrete probability distribution table. Hope you have understood what is a probability distribution. Now we will move on for the calculations of the mean, variance and standard deviation of probability distribution. Before moving on, I wanted to tell you one thing. Whenever probability distribution is there, the sum of all the probabilities must be equal to 1. Unless this sum equal to 1, it is not called as valid probability distribution. You can observe here 1 by 4 plus 2 by 4 plus 1 by 4. So 1 by 4 plus 2 by 4 plus 1 by 4 is definitely equal to 1. So this is a valid probability distribution. Now, first point, whatever I told, I'll write it here. Probability, sum of all the probabilities is equal to 1. Then only it is called as valid probability distribution. Okay. Now we will see what are the formulas of mean, variance and standard deviation. What is mean? In statistics, we always think whenever we talk about mean, we think about average value. That means adding all the values and dividing it by total number of data points. But in case of probability distribution, you cannot add all the values of x and divide it by n, because every data point in probability distribution has different weightages, different probabilities. So we need to follow this formula, mu equal to summation of mean. Mu means the notation for mean. Mu is equal to summation of xi multiplied by P of xi. Let us take our example of tossing 2 coins. We had x values 0, 1 and 2 and their probabilities, corresponding probabilities 1 by 4, 2 by 4 and 1 by 4. So we will understand the calculation with the help of this simple problem, and any problem, it's the calculation is same. So here mean is xi multiplied by P of xi. So mean is equal to xi, all the values of x we need to consider. First value of x is 0. It has to be multiplied to its probability, which is 1 by 4. So 0 multiplied by 1 by 4. And we have to do the same thing for all the values of x, and we have to do the summation of them. So I'll add them, I'll do the sum. 0 into 1 by 4, then 1 into 2 by 4, plus the last value is of x is 2 is into its probability is 1 by 4. So you can use your calculator to calculate all these values. So since this is simple one, I can do it manually. So this is 1 by 2, 0 plus 1 by 2 plus 1 by 2, which is 1. So the mean value for this example is 1. Okay. Next, let us understand what is the variance. So variance will give you an idea of how far or how close the data points are to the mean. Variance, suppose you get a big value, then the data points are far from mean, and if variance is very small, then they are all very close. So now let us take this example. First let us take formula for variance. Two formula I have written here. You can use whichever is convenient to you. So variance is denoted by sigma square, and the formula is, I'll take the second one, xi square multiplied by p of xi. It's very easy to remember because mean is xi into p of xi. Instead of xi, we have xi square here. Xi square into p of xi, and once this summation is ready, you can subtract mu square finally. Subtract the mean square which you have already calculated. So let us take the example, this table. First value of x is 0. So let me take 0 square multiplied by its probability 1 by 4, plus next value is 1. So 1 square to be multiplied to its probability 2 by 4, and third one is 2. So 2 square to be multiplied to its corresponding probability 1 by 4. And finally we need to subtract the mean square. Mean is 1 in this problem. So 1 square. So what will happen? This is 0 plus 2 by 4 is 1 by 2 plus 2 to the 4, gone with 4. So this is 1 minus 1 square. 1 square is also 1. So finally you got variance as 1 by 2. So variance is 1 by 2. Okay. Once you get the variance, you can calculate the standard deviation. Standard deviation is just the square root of variance. So standard deviation is denoted by sigma, which is square root of variance. So these are very easy to calculate, mean, variance and standard deviation. So you can practice with more examples. For your practice, I have written two problems here. So first thing, you check that this sum will be equal to sum of all the probabilities equal to 1. So definitely it's 1. 0.2 plus 0.35 is 0.55. 0.55 plus 0.25 is 0.8. This if you add 0.95, and finally if you add this, it is 1. And mean, the formula sum of xi p of xi, you will get the solution as 3.5. You can cross verify, and similarly variance you will get 1.25, and standard deviation will be square root of variance, which is 1.118. And to prepare your own distribution table, I have given a random experiment where 3 coins are tossed. 3 coins means you will have 8 outcomes: HHH, HHT, HTH, HTT, and THH, THT, TTH, and TTT. So like previous problem, you can prepare your own distribution table where x denotes the number of tails. Just for one example, x denotes the number of tails. So here one tail, here also one tail, here also one tail. In these 3 cases, x will be 1, x equal to 1. Probability of 1 is 3 out of 8. So remaining cases you can see yourself, and you can prepare your own table, and also you can find the mean and variance. So one more example I'll give you where probability values are not given. You have to find yourself, and some information is given. So what is the information? Probability of 0 is k, probability of 1 is 3k, 2 is 5k, 3 is 7k, 4 is 9k, 5 is 11k, and 6 is 13k. So first thing we need to find the value of k. Unless we find the value of k, we will not know what is this, what are these probabilities. So what is the idea? Idea is very simple. We know that sum of the probability is equal to 1. So sum of all these probabilities. What are the probabilities given here? First probability is k, second is 3k plus 5k plus 7k plus 9k plus 11k plus 13k plus 13k. That summation must be equal to 1. So you can solve this equation in different problems. It could be different equation, like it can be linear, it can be quadratic, whatever it is. There it will be a high school mathematics. So easily you can calculate. So in this example, what is this? K plus 3k is 4k, 9k, 16k plus 9 is 25k, and 36k, and totally 49k's. 49k is equal to 1. What does it mean? K value is 1 by 49. So we got to know what is the value of k. And these probabilities, cumulative probabilities, very easy to calculate. First probability, what they are asking is probability of x less than 4. So probability of x not equal to 4 here, it is less than 4. Equal to 4 means it would have been this one, 9k. But x less than 4 means we have to consider all the values of x that is less than 4. What are the values x less than 4? It is 0, 1, 2 and 3. So it will be p of 0 plus p of 1 plus p of 2 plus p of 3. So what are these probabilities? P of 0 is 1k, p of 1 is 3k, p of 2 is 5k and p of 3 is 7k. So totally 16k. And also we know the value of k, so you can substitute that also, 16 into 1 by 49. This will be the first probability of x less than 4. Similarly, you can calculate other probabilities. X greater than or equal to 5. That means it includes 5 and 6. And third problem, p of 3 less than x less than or equal to 6. So it is 4, 5 and 6 that you can add and get. And finally, you also know how to calculate mean, variance and standard deviation. Now you know the value of k. So you will know what are all these probabilities. And with the formulas what we have studied, you can use them to calculate mean, variance and standard deviation. So hope you have understood what is discrete probability distribution. And moving on, we will study two important distribution under this. One is binomial distribution and another is Poisson distribution. Let's continue with our next topic, binomial distribution. I'll start with a simple example so that you understand concept and also application of binomial distribution very easily. So let me take an example of tossing a coin. So when we toss a coin, in the sample space there will be two outcomes. One is head and other is tail. So when we toss a coin, we know that either head will appear or tail will appear. Suppose I am interested in getting head. So this is my success. So whenever head appears, that I will consider as my success. Now what is the probability of my success? Definitely we all know it's 1 by 2 or 0.5, because when we toss a coin, the probability of getting head is 0.5. Suppose I am interested in something more, like I will not restrict for tossing only one time. Suppose I do this experiment repeatedly. Say for example, I want to do the same experiment 7 times. And I have defined that getting head is my success. And if I want to calculate what is the probability that out of these 7 times, what is the probability that 5 times I will win. So what is the probability that 5 times I will get head? Okay, if I am interested in this type of questions. Here binomial distribution will help us. The probability mass function of binomial distribution is NCX P to the power x and Q to the power n minus x. So this is the probability mass function of binomial distribution. This will give you probability of exactly x success out of n trials. So if we do an experiment n times, if I want to calculate probability of x success, then I can use this. So in our example, we are tossing the coin 7 times. That means my n is 7. 7 times I am doing this experiment, and I am interested in 5 success. So my x is 5 here. And what is this small p? Small p is the probability of success in only one trial. Instead of doing 7 times, if I do only one time, what is the probability? The probability of my success. That already we have discussed. It is 0.5. So my p value will be 0.5. And what is q? Q is probability of failure. So it is very easy to calculate. Whenever you have p, q can be calculated with the help of the concept of complement, 1 minus p. So q will be equal to 1 minus 0.5 here, which is also 0.5. So now we have all the values required, and if we can very easily calculate this probability. Let me do this one for you. It is 7c5, 0.5 power 5, x value is 5, and another q value power n minus x. N is 7 and x is 5. So 7 minus 5 is 2. And you can use your scientific calculator to calculate this, or if you want to know it how to calculate manually, 7c5. So we all know NCX formula. NCX formula is n factorial divided by x factorial into n minus x factorial. So this will be 7 factorial divided by 5 factorial, and 5 minus 5 is 2 factorial multiplied by 0.5 power 5 multiplied by 0.5 power 2. So this calculation, when you do, you know that 7c5 will be 21, and multiplied by these two values will give you approximately 0.164. That means almost 16% chance is there that 5 times I'll win this game. 7 times we are playing, and 5 times, the probability of 5 times winning is 0.164. So hope you have understood when to apply binomial distribution. And PMF, once you have the PMF, you can prepare the probability distribution table also for this, because whenever you play a game 7 times, it's not necessary that you will win 5 times always. There is a possibility that you will not win at all. So your success will be 0 times, or you may win only 1 time, or you may win 2 times, you may win 3 times. So all the possibilities are there. X values, if you consider x as the success, 0 success you may have, 1 success, 2, 3, 4, 5, 6, 7. And you can calculate all these probabilities by giving different values for x in the PMF. So for example, C5 5 success of 5 success we have already calculated. It is 0.164. Suppose you want to know what is the probability that you will have 3 success. So instead of 5 here, you have to replace it by 3. Just you have to replace the value of x. So in this power also, this will, instead of 5, this will become 3, and power also, instead of 5 it will become 3, and this the other power 7 minus 3 will be 4. So if you want to calculate this, and 7c3, we know that it's 35, and the final value will be 0.2734. So 0.2734 will be the probability of 3 success out of 7. Okay. Similarly, by changing the values of x in the same formula, what is there in the box, you can replace x by these values, x equal to 0, 1, 2, 3, 4, 6, 7, and you can fill this table. So once you have done this, your probability distribution table will be ready for the binomial distribution. And you can also observe that if you add all these values, the sum of the probabilities will be equal to 1. And to calculate the mean, you don't have to use the general formula what we discussed in our last topic. The mean of binomial distribution will always be equal to n into p. That I have given it in this slide. Mean formula is n into p. In this example, our n value is 7 and p value is 0.5. So the mean of this binomial distribution will be 3.5. And similarly, you can find the variance. Variance formula will be n into p into q. So n into p already we got 3.5, and q also we will multiply to this. So this will give you the variance. So once maybe approximately it is 1.75, and once you have the variance, you already know that standard deviation is just the square root of variance. So standard deviation will be square root of 1.75. So what I hope you have understood that binomial distribution PMF is NCX p power x q power n minus x, and this will give you the probability of x success in n trials, where p is the probability of success in one trial and q is 1 minus p, which is probability of failure. Okay. Let us have one more example, and if you have understood completely, you can skip it also. So I'll take an example of this question, what I have written in the slide. The probability that a pen manufactured by a company will be defective is 0.1. If 12 such pens are selected, find the probability that exactly 2 will be defective, none will be defective, at most 3 will be defective, at least 2 will be defective. So 4 different questions are given, and we have to just understand what is n and what is p and what is x. So what's happening here? We are having a lot of pens, and the probability that one pen, if I pick one pen, the probability that it is defective is 0.1. So my n, I am doing this experiment 12 times because 12 pens I am selecting. So 12 pens I am selecting, and my x is number of defective pens, because this is the random variable what we are discussing about, defective pens. So how many are defective? The number of defective out of these 12 pens. I have selected 12 pens, and my success is getting a defective pen. So n is 12 and x is number of defective pens, and p is given the probability of defective. If I select one pen, the probability that it is defective is 0.1. So if p is 0.1, what will be q? Q will be 1 minus p. 1 minus 0.1 is 0.9. Okay. Now you can take, you will be ready with your PMF. What is it? P of x is NCX. We know that n is 12. So 12CX p power 0.1 power x, and q power 0.9 power 12 minus x. And let me take the first question. The probability of exactly 2 defective. That means x value is 2. I have to calculate p of 2. So it is 12C2 0.1 power 2 multiplied by 0.9 power 12 minus 2, which is 10. So this you can calculate, and the value of this will be 0.2301. So the probability that out of 12 pens, the probability that 2 pens will be defective is 0.2301. Approximately 23% chance is there that 2 pens will be defective out of 12 pens selected. Let me take the second question. None of them will be defective. None of them. So no pen will be defective. All the pens will be good. So probability of 0 defective. So x is the number of defective and x is 0 here. So this will be 12C0, 0.1 power 0 and 0.9 power 12 minus 0 is 12, which is equal to 0.2824. Okay. And now the question is, at most 3 will be defective. What does it mean? At most 3. That means there cannot be more than 3 defective pens. Maximum 3 defective pens will be there. So it is the probability of x less than or equal to 3. The defective pens should be either 3 or lesser than that. It cannot be more than 3. So probability of x less than or equal to 3 means there can be 0, because x values that are less than 3. P of 0 plus P of 1 plus P of 2 plus P of 3. So all the 4 probabilities you can calculate separately and you can add them one by one, and its answer will be 0.9743. And the last question, at least 2 will be defective. At least 2 will be defective. So what does it mean? Minimum 2 pens will be defective. So how do you calculate this? Minimum 2 will be defective. Probability that x is greater than or equal to 2. Minimum 2, that means it can be more than 2. So what are the values, different values x will take? X greater than or equal to 2 means it is 2. It can be 3 also, it can be 4 also, it can be 5 also, it can be 6, 7, 8, 9, 10, 11, 12. So too much calculation. Instead of doing this many calculation, we can use one more concept of complement. Probability of x greater than or equal to 2 is 1 minus probability of its complement, x less than 2. Greater than or equal to 2, complement is x less than 2. Okay. So this will be 1 minus, what are all the values? X less than 2. It is 0 and 1. Only 2 values. Calculation will be very simple. And this you can calculate this 12C 0, 0.1 power 0, 0.9 power 12, and P of 1 is 12C 1, 0.1 power 1, and 0.9 power 12 minus 1 is 11. So you can calculate and cross check that. The final answer will be 0.3409. So hope you understood the application of binomial distribution, and you can have practice with different examples. I have written some of them. Let me explain this. The number of telephone lines busy at an instant of time is a binomial variant with probability 0.2. That means the x is the number of lines busy, and the probability that one line will be busy is 0.2. Immediately you can get to know what is q. Q is 1 minus 0.2, which is 0.8. And you are choosing 10 lines. So n will be 10. So what will be your P of x? It is 10cx 0.2 power x multiplied by 0.8 power 10 minus x. And 2 problems are there. In first problem, 5 lines are busy. So you can put x equal to 5 and calculate this. And in the second question, all lines are busy. All lines, all 10 out of 10. So I can put x equal to 10 and calculate. Let's continue with our next topic, Poisson distribution. So this distribution is a limiting case of binomial distribution where n is very big compared to p. So the probability mass function of Poisson distribution is mu power x e power minus mu divided by x factorial. In this distribution, both mean and variance will be equal to this mu itself. Suppose you have a Poisson distribution where with mu equal to 2 power x e power minus 2 divided by x factorial, then the mean of this distribution and variance of this distribution both will be equal to 2, and standard deviation will be square root of 2, because standard deviation is square root of the variance. And now suppose you know the values of the mean, you can use it directly to calculate the values of the probability, or you can also use, suppose you know what is n and what is p, as we have discussed in our binomial distribution case, mu will be equal to n into p, and since Poisson distribution is a limiting case of binomial distribution, you can use the same formula to calculate the mean here also. So mean is equal to n into p. So let me explain this with an example. The probability that an individual suffers a bad reaction from a certain injection is 0.001. Determine the probability that out of 2000 individuals, exactly 3 will suffer bad reaction, and second question is more than 2 will suffer bad reaction. Here what is x? X is the number of people suffering from the bad reaction. Number of people suffer bad reaction from that injection. So out of 10,000 people, how many will suffer? It will be a very small probability, because everyone will not have the side effect. So in this problem, it is said that the probability is just 0.001. That means out of 1000 people, there is a possibility that one person will be affected. And P is there, and we are trying to calculate the probability for n 2000 individuals. So n is 2000 here. So n is there, p is there. So we can calculate what is the mean. Mean is n into p, and n into p is 2000 multiplied by 0.001, which is equal to 2. So mu is 2. So our probability mass function will be p of x is equal to 2 power x e power minus 2 divided by x factorial. I am just putting it in the formula for PMF of p of x, which we know that it is mu power x e power minus mu divided by x factorial. Here mu is 2, so this will be 2 power x e power minus 2 divided by x factorial. Now the first question is exactly 3. Exactly 3 will suffer. That means I am calculating probability of x is equal to 3. I just have to replace x by 3. So it is 2 power 3 e power minus 2 divided by 3 factorial. And you calculate this, and the value will be 0.1804. That means out of 2000 people, the probability that exactly 3 people will suffer is almost 18%. And similarly, you can take the second problem, which says you have to calculate more than 2 will suffer bad reaction. More than 2 means probability of x more than 2, greater than 2. And here also, as I have already explained in case of binomial, when the calculation is very big, you can go for complement, because if you try to calculate this directly, x can be 3, x can be 4, x can be 5, and x goes up to 2000, which is very huge. It's very difficult to calculate. So you can go for the complement, 1 minus p of x less than or equal to 2. And what are the values? 1 minus p of 0 plus p of 1 plus p of 2. So from 1 you need to subtract sum of these probabilities. And what will be that? So first one, P of 0. P of 0 means it is mu power x, mu power 0. So 2 power 0, e power minus 2 divided by 0 factorial, which is 1, plus P of 1, 2 power 1, e power minus 2 divided by 1 factorial, which is also 1, plus 2 power 2, e power minus 2 divided by 2 factorial, which is 2. So you can calculate this and you will get the answer as 0.3233. So 32% chance is there that more than 2 will suffer the bad reaction from the injection. Okay. So let us take one more example, and definitely, as I have already mentioned, you can skip the video if you have understood this completely. Here n is 200 because we are doing it for 200 fuses, and given that 2% of the fuses manufactured by a company are defective. That means if you choose one fuse, the probability that it's defective is 2%. 2% means it is 2 divided by 100, which is 0.02. And N and P you can use to compute mean value. So 200 into 2 by 100, which is 4. So mean is 4. So your P of x will be 4 power x e power minus 4 divided by x factorial. So you can take the questions one by one now. Has no defective fuse. No defective means x value is 0 because x represents the number of defective fuses. So P of 0 is 4 power 0 e power minus 4 divided by 0 factorial, which is approximately 0.0183. And at least one defective. What is at least one defective? At least one means probability that x is greater than or equal to 1. So instead of calculating 1 to 200, you can go for the complement. 1 minus P of x less than 1. Less than 1 means 1 minus P of, only one value is there which is less than 1, which is P of 0. So it's 1 minus 0.0183, which will comes out to be 0.9817. So similarly, you can calculate other values like exactly 3 defective. That means P of 3 you have to calculate, which is 4 power 3 e power minus 4 divided by 3 factorial, and 3 are more defective. Again, P of x greater than or equal to 3. You can go for the complement. 1 minus P of x less than 3, and 2 to 4. You can add P of 2 plus P of 3 plus P of 4. So, hope you have understood the discrete probability distribution, and under that 2 important distributions. One is the binomial distribution and another is Poisson distribution.